Welcome to Lab. We will be learning about solution preparation today. Please review your text about these concepts. Let's go over some safety. As always, goggles and apron must be on at all times. People with long hair need to put their hair up, and any dangling clothing or accessories, such as jewelry, need to be taken care of. This is called a 25 milliliter burette. It is used for dispensing a specific volume of liquid into another container. The numbers go down and the smaller lines indicate 0.1 milliliters each. You set up the burette by pulling out a few items: a ring stand, a metal rod, be careful pulling out the rod, and a burette clamp. Screw the rod into the ring stand and slide the burette clamp onto the rod, and turn the screw on the burette clamp. It is best if one end of the burette clamp is facing you. This is where the burette is placed. Open the clamps by squeezing them together, place the burette between the clamps, and release. Before you fill the burette, make sure that the stopcock is closed. It is closed when the handle is sideways or perpendicular to the burette. It is fully open when the handle is vertical or parallel to the burette. Put a small funnel in the top of the burette. If using deionized water, no funnel is necessary, and a waste beaker underneath, and then add the liquid to the burette. Add more liquid than needed, and open the stopcock by turning the handle vertically for a moment. This fills the tip of the burette. Check to make sure there are no air bubbles in the tip. If there are air bubbles, open the stopcock again for a moment. If necessary, add more liquid and adjust the meniscus appropriately. Once you are ready to dispense the liquid, you have to remove the funnel. Once you have a container underneath the tip, carefully open the stopcock. You can open the stopcock enough to let out the liquid in drops. Make sure you are looking at the meniscus and the drops to make sure you dispense the correct amount. We will be using a spectrophotometer called a Spec20 or Spec20 for short. A spectrophotometer sends light to a sample at a certain color or wavelength. Some of the light is absorbed and some is transmitted. A detector can detect the amount of light transmitted and mathematically show the amount absorbed in a meter. You will be recording the absorbance, which is on the bottom of the white display area. Please note that the tick marks are different depending on the two numbers they are between. For example, the tick marks between 0 and 0.05 have values of 0.01 each. Between 0.7 and 0.8, there is only one tick mark that has a value of 0.05. So make sure you record the correct decimal places and values. Spectrophotometers use a special test tube called a cuvette. The cuvettes have a white line on them that lines up with the black line on spectrophotometers. You have to wipe down the cuvette with a Kim wipe first. No paper towels, please. They will scratch the cuvettes. Spectrophotometers base the absorbance reading versus a sample without the compound you are measuring, which is called a blank. In this experiment, the blank is deionized water. You need to put the blank in the Spec20 first and adjust the Spec20. Here's how. Prior to putting anything in the Spec20, adjust the 0% T knob so that the Spec20 reads 0 on the top line in the white display area. Put the blank sample cuvette in the Spec20 with the white and black lines lined up. Close the lid and adjust the 100% T/0A knob until the white display area shows 0 absorbance. Remove the blank cuvette and place it in your test tube rack. Put your sample in the Spec20 with the white and black lines lined up and close the lid. Record the absorbance reading. You must repeat the blank adjustment before every sample. You will be creating a graph based on your absorbance readings of the known molarities. The concentration is on the x-axis as written in your lab manual, and the absorbance is on the y-axis. Plot your points accordingly. Using a ruler, draw a trend line that fits as many points as possible. Please note that a trend line does not connect the dots. You may not be able to fit all points perfectly. In order to determine the concentration of your unknown sample, find that absorbance along the y-axis and draw a line from the y-axis to the trend line and draw a line straight down. Where this line hits the x-axis is the concentration of your unknown. If you need help with any of the write-up, please speak with your instructor.